So if I want to pay attention to the motion of a center of mass of a system of particles, not only do I need to know where that center of mass is located, so the position of the center of mass, not only do I need to know the velocity of that center of mass, but I also want to know how that velocity is changing, so I need the acceleration of the center of mass. And what we'll see is that how we're going to calculate the acceleration of the center of mass is very similar to the way that we calculate both the position and the velocity. So in this case, again, with my three particles, if I know what the accelerations are of the individual particles, then again I can calculate the acceleration of the center of mass for the system by calculating the mass-weighted average of the acceleration of the particles. And so all we've done is said, instead of position or velocity, if I want the acceleration of the center of mass, then again I'm going to take each mass, multiply it by the acceleration vector of that mass, sum all those up, and then divide by the total mass of the system. It's vector addition. It's just vector addition where we're weighting each acceleration vector by multiplying it by the mass of the particle. So the larger the mass of the particle is, the more weight that's going to carry in terms of thinking about the acceleration of the center of mass. So in terms of breaking this up into components, again, this looks very similar. I'm going to start by redrawing the individual acceleration vectors from the origin. That's going to make it easy for me to break these vectors up into their components, because it's the components that I need to plug into the component equations. So again, as a vector equation, this is going to break up into a component equation for each relevant dimension in the problem. So in this case, because I have things accelerating in the xy plane, then I'm going to have an x and y component equation. And so the x component of the acceleration of the center of mass is going to be given by m1a1x plus m2a2x plus m3a3x. So again, taking the mass and multiplying it by the x component of each individual acceleration vector, adding all those together, then dividing by the total mass of the system. Y component equation, same thing. It's just now instead of using x components, I need y components for all three of those acceleration vectors. So I have m1a1y plus m2a2y plus m3a3y. So adding all three of those together, dividing by the total mass of the system.